Hi folks, so this is one of 3 videos presenting the information that we found within chapter 1 of the introduction to CyBOK. So this video contains some foundational concepts that all of the information in the other chapters will rest upon. So we'll start out by looking at the definitions of cybersecurity and information security that CyBOK use, and we'll make some comparisons between them. Following that, we'll look at the objectives of cybersecurity, and we'll touch on risk management and consider the benefits of looking at security from an adversarial perspective. So after this, we'll look briefly at the we'll briefly discuss security controls, what we mean by security controls, and what we mean by security failures and security incidents. And we'll look at the differences between failures and incidents and how they relate. All these concepts relate to one another in practice. And then finally, we'll take a brief look at risk management, which is a topic that will be explored in more depth later in the module. Okay, so it's pretty common to hear people referring to cybersecurity and information security a lot. So there's these two terms that get used, and it's always useful to have a precise definition of the terms that we're working with when we're reading through a text or a resource. So let's have a look here at the CyBOK working definitions for both of them, and then we can do some comparisons and see what the difference is. So the CyBOK uses the definition from the UK National Cybersecurity Strategy, and it goes like this. So cybersecurity refers to the protection of information systems, hardware, software, associated infrastructure, the data on them, and the services they provide from unauthorized access, harm, or misuse. So this includes harm caused intentionally by the operator of the system or accidentally as a result of failing to follow security procedures. So yeah, as you can see, this is all about protecting information systems, which they've defined as hardware, software, and associated infrastructure. Protecting the data, the information systems, the data, and the services that they provide from unauthorized access, so people who are not allowed to be on the system, and misuse from either intentional misuse or unintentional misuse, so things that step outside of a defined security policy. Okay, so that was our cybersecurity definition. So now let's look at the information security definition. So CyBOK uses ISO 27000 definition, and ISO 27000, if you're not aware, now you will be by the end of your course, but this is a set of widely used standards for best practice in information security, which are set out by the International Organization for Standardization, which you would think would be iOS rather than ISO, but yeah, there we go. So here's the definition. So information security: preservation of confidentiality, integrity, and availability of information. In addition, other properties such as authenticity, accountability, non-repudiation, which means that can an event be proven to have happened, a security event. So yeah, non-repudiation and reliability can also be involved. So this is a much broader definition than the one we just saw for cybersecurity. So this leans on the CIA Triad, so you will have heard about this elsewhere in the course, but this is a way of describing the objectives or goals of preserving or defending, protecting an asset, basically. So yeah, you've got confidentiality, integrity, and availability. So yeah, you would. So there are some other concepts as well which are relevant to both cybersecurity and information security. So it looks pretty much like, by these definitions, that cybersecurity is just like a subcategory of information security, which focuses pretty much on the data on information systems, which they describe as like hardware, software, and infrastructure, rather than just in general. So cybersecurity objectives. So yeah, I got a little ahead of myself on the last slide, but as we saw in ISO 27000 definition of information security, common way of describing or defining the goals and objectives of cybersecurity or information security in general, sorry, as well as cybersecurity, is using the CIA Triad. So when we say we're protecting information, what is it about the information or data that we're protecting? So confidentiality. So we want So it's like the privacy of the information. So we want to make sure that only the people who should have access to specific resources do have access to it. So those people and those people alone. So do we have things like access controls for different users or processes? So we call them subjects. Do different subjects have different access levels? And then we'll get into some themes in one of the other videos about how best to define these different access control levels based on what permissions different end users actually need. So you might not have, for example, a receptionist at an organization should probably not have access to the production database or something like that. So yeah, we want to make sure that so the information says private, right? So integrity. So we need to make sure that the data that we say, so that the data is correct, basically. Imagine if you think about a bank balance on a bank account. If that data was not correct and you had £500 less than you thought you had or whatever in your bank account, then that'd be a bit of a problem. You need to make sure that the data that is supposed to be there is right and nobody's got in or edited it, or that the system's not broken in a way that gives you bad data integrity. So then we've got availability. So this is how available is the system compared to what it should be. Do you have are the authorized parties that we are the authorized individuals or parties actually able to access the data when they need to, or has the system been is it offline for some reason? So this can actually be a security problem, because if you think about denial of service attacks, they aim to take a service offline, which stops people from not being able to access it. So it all really comes down to managing and minimizing risk. So we need to think about things like how likely security incidents are, how likely are security controls to fail. I will define those terms next slide, getting a bit ahead, but yeah, things like how much impact do various incidents and failures have on the organization in terms of what are the costs associated, are they breaking any rules or regulations which might end up incurring them fines, how is this all weighed against the price of security controls that they're employing, or including things like how much training are they given to the staff, do they need, these things are all there are different requirements or expectations based on the type of organization that you've got. So as an example, you would obviously have a different security posture and profile for an organization that was dealing with very sensitive information, like national security level stuff, versus a fast food restaurant, for example. The cost of losing data or having security incidents in one context is completely different from the other, so that when it comes down to purchasing or determining how many security controls you have, yeah, it all depends really on the context. So there's two approaches really towards managing risk. So there's prevention and mitigation. So you want to prevent something from happening and mitigating against the damage. So you're trying to put controls in, for example, you might have access controls and you might have an application which is sandboxed, so that if there are any security problems happening within the application, say the process gets exploited and someone takes over that process, it's within a self-contained environment, which is difficult for an attacker to get out. Obviously, they can't get back to the main base system. But then you've got other things the other way of doing it is detecting and responding to it. So some of the ways you can manage risk and manage the risk involved in incidents and failures might be to use forensics and incident response teams that will come afterwards. So you might have things like intrusion detection systems, or malware detection, anti-malware detection systems, or login, system login, that will help you detect when something's gone wrong and aid you in responding to it, so you can see what the damage is really, what has been, if you've had a security incident where there's been a compromise of one of your systems, what's been taken, what have the attackers done, what have they managed to find out, have they left back doors, things like that. So these both manage risk in different ways, really. It's like, for the first one, you're trying to prevent a thing from happening, but that's not the only thing you can do to minimize risk. You can also detect it. You can also like improve your capabilities for detecting and responding to incidents, because otherwise you might not know that anything's actually happened. Or if something does happen and you're suspicious of it, you might not be able to actually find out because you've not set up the policies and procedures in time. You might not be able to find out exactly what has gone wrong. So the definitions of objectives that we described, they imply that there's something working against us, right? It's like an adversarial model used in security modeling. So this could be an actual, like a person or a team of people. So it could be like a hacker or a social engineer, something like that. Or it could simply be like natural processes, like the system's degrading over time, which could cause like accessibility or integrity issues. Or it might be that as the system is developed over time, new features new features or changes in the system lead to unforeseen circumstances that might lead, like, I don't know, it might open a hole, a security vulnerability that an attacker can use that hadn't been considered beforehand. So yeah, so when we're understanding adversaries, you've got threat modeling. So threat modeling involves identifying and analysing all of the threats and the mitigations that we have in place to try and protect our asset. So in terms of cybersecurity, it's usually like digital data sat on an IT system somewhere. So we need to identify the components and map out how they all interact with each other. And we've got special considerations for like trust boundaries. So trust boundaries are basically places within the application where different components that interact with each other have different privilege levels. So you might have, as an example, good examples like sudo in Linux systems. So if you run a program with the sudo binary, it's going to run in the context of another user. Usually by default it's running as root, but that's a trust boundary because you're going from the access control level context of just like a standard user to then temporarily run some commands with elevated trust. So there are probably loads of, like, depending on the application or the system that you're modeling, there are loads of different places where this kind of thing happens. So you might have like a website, that talks to your database. It might jump through, depending on the design, it could go through a bunch of different trust boundaries on the way, but these are important places to be extra careful, because these are the places where if an error occurs in the like crossing of the trust boundary, like for example with the I'll stick with root with sudo, going from basic, like just a standard user to root. Like if you apply that, if you allow people to use that mechanism incorrectly, it can lead to the user being able to run things as root, which it shouldn't, which you don't want it to be able to do. So for example, if you set I'll just leave it there actually. I'll give a couple of examples. So then you've got vulnerability analysis. So this is the other part of understanding your adversaries. I guess it's more like understanding your own system and its weaknesses and potential weaknesses. So yeah, vulnerability analysis and vulnerability assessments are pretty similar, but you use them to identify the weaknesses in the system. So this can be a bit more technically involved than just like high-level mapping out the different areas. You're looking at like using specific technologies. So things like, what infrastructure are you using? Are there any like what network services are exposed to the internet? What versions of software are running on those? Are there any versions with known vulnerabilities? You might also do like vulnerability analysis on particular parts of the system. So you might look at you might have a web application for like internet-facing application that you might hire a pen tester or someone who works in web application security to do an audit of, just to make sure that there are no vulnerabilities in there. Because like if it's some software that you've created your like an in-house piece of software, rather than using some packaged off-the-shelf thing, it might not have been exposed to, like, there might be vulnerabilities there that you've just not discovered yet. Okay, so controls failures and incidents. So failures in one or more security controls can lead to security incidents. Can is important. So security controls, mentioned it a couple of times, but security controls are pretty much just mechanisms what we put in place that are intended to support the goals of security, so the confidentiality, integrity, and availability of information. And these are things which can impact people, processes, and technologies. So you've got if or when an adversary manages to get past one of these controls, so it could be anything really. It could be like access controls, as I've said. It could be policy changes. It could be like firewalls, like web application firewall, and actual like network firewall. And it could be things like anything you can think of that people use to improve security. It could be password policy. It could be improved login or system like intrusion detection stuff. All these things are security controls. So if an adversary using the adversarial model, if an adversary manages to get past one or more of these security controls, so i.e. when these controls fail, there's potential for a security incident. So it's not always the case. So you might have an adversary who can get past one control, but there might be others in place which stop the actual incident from taking place, but there's still been a failure in security control. So that's why the can lead to is there rather than just, it doesn't always happen. So you might have, as an example from like physical security, you might have a door with multiple locks on it, and an attacker might pick one lock, but it's not, which is that lock's failed, that control's failed, but there are it's still not done enough to quite compromise the confidentiality, integrity, or accessibility of the asset that you're protecting. So yeah, it's another thing is it's not always necessary to bypass the security controls for a security incident to take place, because there might not be any to begin with. So yeah, it's not a necessary condition. So security incidents, they can also occur when processes change in a way that makes the original control no longer do its job correctly. So these are things like there might be changes in the system. As an example, I've got a couple of images and examples of that. So here's one. So there's a gate here. There's a fence, a gate with no fence. So you can. There was probably originally a fence attached to this gate. I imagine, I don't know, or maybe this was in the process of someone building the fence. They put the gate up first. But yeah, you can just walk around the fence. If the back door, like compare this to like being a firewall being turned off and the back door is just wide open, you can just walk straight around it. So something might have changed. Here's another one. Something might have changed, which an additional implementation like here, where you might have the environment might have changed, which makes your security control no longer do what you want it to do. And it's you need to be aware of changes in the system or in the surrounding environment that can make your your previously well thought out security controls now redundant. So you need to review these things as changes get made to the system. So risk management. So how do you know when to stop, right? You can keep, in theory, you can keep applying more and more security controls until you run out, right? But there's always like, you have to think about, as mentioned before, like different contexts of businesses and the information that they gather and have different consequences if a security incident happens. So you have to also think about things like, what is the there's a conflict between like the expected value you're going to get and the return on investment of the things that you're paying money for. So yeah, you might have a bank. If you think about the different organizations having different risk profiles, you got like, it's completely different if you're a bank versus like a public library, or if you work for the Ministry of Defence. So this is all things that you'd be, the risk assessment group exercise involves looking into this area in detail and trying to come up with an organisation and assess the risk. So yeah, and as a recap, in this video we've defined cybersecurity, information security, and compared the two definitions. We've identified that cybersecurity is a subcategory of information security. We looked at the objectives through the CIA Triad and risk management. And then we looked at what we meant by security controls, failures in controls, and security incidents. And finally, we looked at briefly at risk management, which is the topic we're going to return to in depth in another video. So thank you.